Hi, everyone. In this session, I'm going to be talking about Python data structure. In particular, we're going to discuss the data structure string, set, list comprehension, tuple or tuple, data dictionary, class, and objects. We're going to just discuss all of them, and then we're going to demo some of the examples on Visual Studio Code, some of them on PyCharm, some of them on JupyterLab, and this is going to be on Windows platform, and this one is going to be video number 4 of the videos that we have done so far. The discussion is on Windows Professional Edition, Windows 11 operating system, and the operating system that we use. This is video number 4. Again, we're going to use JupyterLab, Visual Studio Code, and PyCharm IDEs. The Python data structure is really helpful whenever you are just programming. It's the building block of your data structure. Whatever you do with the data, you are using these kind of strings, sets, tuples, list comprehension, tuple comprehension, data dictionary comprehension, data dictionary itself, or classes and objects, and you're manipulating data, and whatever IO input output you're receiving through your program and sending to other program or to the screen or to the printer or to a file, and basically those data structures are being manipulated by your algorithm or programs and snippet of codes. And I want to just thank you for watching our videos on at MyWebUniversity. The YouTube channel is MyWebUniversity on YouTube. Please, if you haven't subscribed yet, subscribe and like our videos and support our videos and share with your favorite friends and loved ones and family members and cousins and neighbors and classmates, so they all could enjoy the education here that is available for free, and they will just learn a lot from it. This is the actual YouTube channel, youtube.com/@mywebuniversity. All the topics related to computer science related topic, whether it's computer science courses that I taught at Pasadena City College, like Python, C++, Bash shell scripting, Unix, and anything that I taught there, I provided the videos already about 2-3 years ago, or maybe 2 years ago, and the video were done in 2020, 2021, but I posted them on 2022. And then I'm still using my weekend and holidays. Today it was my day off, so I'm in your service to help you out. And I'm getting a lot of nice comments from people that they are observing whether there's bash scripting or shell scripting or Python programming or operating system like Linux, Rocky, Red Hat, Ubuntu. All of those ones, they are saying that this is a treasure and they're enjoying it. They're just watching it and they're subscribing it. I'm glad you like it, and I hope what I do is spend my time, it serves the purpose in the community, and you pass on the knowledge to the next generation when you learn it. And if you are on the same topics and discussing it and making YouTube, please feel free to use any of my YouTube knowledge information and share it with your friends and family ones, as you have already done, some of you. And I'm very happy that knowledge is shared. When we share it, everyone, we say knowledge is power. By sharing, we make everybody powerful. Everybody is going to be educated and they do good at their school, at their work, at their community. And I hope you pass on the knowledge to the ones that they need your help. So with that in mind, let's get started with this discussion for today. As you know, I'm going to be covering a number of them on Windows platform. So the first thing I'm going to do is open command prompt on the Windows, and then as you can see, I'm on a Windows operating system. If I do cd/, I just go to the C drive and then I do a clear screen. You can see that this is the prompt C drive. And if I type in host name, it shows the name of the host name is algorithm. System info, pipe more is going to give me all the system information on the system. It says that I'm running Microsoft Windows 11 Professional Edition. The name of the host name, as I showed you, is algorithm. And this is the build version 10.0. Whenever you open a command prompt, automatically you're dropped into the command prompt of build 10. But if you type in system info, find /i OS name, you could see it is Microsoft Windows 11 Professional Edition. If you want more detail, like some more of it, just find to find a string. Now it's going to match everywhere it finds OS as well as name. So OS is matched and name is matched. So there's more argument here that are passed on. The same thing you could do by clearing the screen here. Let me just close this window. So like I showed you that the command prompt, every time you open a command, and then it just says that you're running build 10.0. This is the build of Microsoft Windows Professional 11. And so if I just open 3 command prompts, I have to exit 3 times in order to close those commands. The last time I close it, it will close the session as if I click on X. So now that one is done. This is the other one that I was already on it with that 5 more command. And so when you do the clear screen and run this command with 5 more, in addition to get the operating system information, you also get related to like how much memory you have and what is the processor speed and all that detail are there. And you can also get here on the graphical interface by just typing about, and you just get the about page. It says that it's algorithm, it's 11th generation i7 core and with 3.4 gigahertz. And then we have 8 of them of the core processors, and then you can see the details here. At the same time, if you just say a device driver or device manager, for the device manager, you can look at the processor and then you see the same processor speed, 3.4 gigahertz Intel 7, 11th generation of mini computer. You can see there's 8 of them that I have, 8 cores. So that machine has all the power that I need, and I'm just going to this time not do any VirtualBox. I'm doing everything on the host operating system, which is this algorithm. So on this one, I have already installed Python version. So if I say Python-v, it will say that 3.12 is installed. If I say -- version, it will say the same thing. Also, you can do on Windows Pi -- version. It is pointing to the same Python.exec version. So Python 3. Python 3-v also give you that. So notice that Python 3 is pointing to the older version, 3.10. So if I say echo %path and then %, most likely I have 2 versions of it. So Python 3 is pointing to the version that was 3.10.11, and somewhere here on the path, if I look at it further, and then I can see that Python 3 is after Python 3.12. The path of Python 3.12 is found first. So when you type in Py or Python Py itself, it is going to show the 12 point is. So I just exit out, get into it. I'm going to exit out here. If I say Py-v, it will say 3.12. I told you that when you do path, this path is all information that's showing. But in order to prove that one, you can send this one to a file p.text, and just since I'm on the host C drive, I cannot write as my regular host user ID that I'm here. So if I say set and then say find a string slash find a string slash I and then Wahid, you can see I'm logged on as Wahid. My profile is user Wahid. I'm not root or admin here. So I cannot write by default, which is a good security. You don't want to just log in with a higher privilege on the Windows operating system and have your system on. So if somebody wants to write to C drive program files or something, they cannot write it. That way it is protected. But if I go to the temp directory and I run the same command, now I'm able to write to this one. Now the file p.text is written because that's a temporary location, is like slash temp tmp on Linux or Unix. That is the sticky bit is set. Everybody could write to that directory, and then everybody owns it, and they can read their own file. So now I open the notepad p.text, and you can see this is the path that we were doing it. So I'm going to do Shift Control plus, and I'm going to make the font a little bit bigger by just saying Control P here. Now the file font is really big, so I'm going to say Edit and then search for. Let's look for Edit, Find. Okay, so let's look at it down a little bit more because this thing is right here is fine, and I'm going to just look for the word Python. So notice the first Python that are coming here and the path is 3.12. That's why when I type in Python-V, it is going to run and the code from apps data program files and this one automatically. The next Python, if I do search for the same code, say find Python again, let's say Python again, and then it's going to say, and this is Python 3, but let me search more, Python 3, and then the one that says Python 3, we just have to look at that one, and that one is right here, Python 3.10. That's why, and the other version was shown. So if I close this one, and I say, okay, let's get to Python, and then I say, that is 3.12. So if I say import sys module and then sys.version info, you can see that it is Python 3.12.0, the same thing that was showing here. And then Python sys.version also shows you that is 3.12.0. However, if I exit out of this one and I run Python 3, that is going to run 3.10, and notice that it is 3.10. So if I say import sys, then I say sys.version info, then this is going to show 3.10.11. Same thing that shows above, 3.10.11. And then sys.executable executable, and this one is sys.executable. So now notice that this one, it is showing that the sys.executable is from this Python 3.10, that one. But if I quit out of this one and say run Python, that's 3.12, import sys, and then sys.executable. Notice that one is going to show me the Python exec. The other one was Python 3.10, so the executable is this one for that path. So since the path is telling you where to find Python 3 and where to find Python, and then it's going to just locate it. And sys.version info is going to show the same thing that I showed you earlier. So sys.platform for both of them are the same. Windows 3. Sys. Let's say path. You can see the path of this one is also for Python 3.4, as you can see here. Okay, so we got those ones straight in there, and then we can use whichever one we want to use. At this time, I'm gonna go to programs directory, sorry, clear screen, cd to demo, cd to programs, and then Python. So now I'm on the Python cd, those directories. I'm gonna just say there are chapter, and then I have some chapters that I've already taught Python at Pasadena. So this was chapter 1 through 5, which I covered on video number 3. And this is Python basic. I'm gonna start on chapter 6, and then we jump into chapter 7, 8, and 9, and maybe 14 for covering all of the essential data structure, which are a string, set, list, tuples, data dictionary, and object-oriented programming like class. And so list comprehension, tuple comprehension, all of that will be covered. So let's go to chapter 6 here. Chapter 6. Let's see what chapter 6 is, a string. So I'm going to just open up a number of software here to show you, to demo it. One is that Python idle. When you do the Python idle, you don't need to just run any IDE. The idle is integrated learning environment, so when you type in Python itself, it just get there. So if you have a module called string.py, you could say import string1, string1.py, and it just loads it, and now that module is available. So string1 is there. Every object that a string1 module has declared, you can access them here. So like, for example, print, let's say, a string1.food, to see the food element, it is caged. And then food sub 0 would be the string that is pointing to the C. And food sub 1 would be pointing to A. Food sub 2 would be pointing to K. And then food sub 3 would be pointing to A. And then you can also say for character and food and string1, which is the module name, dot food, which is the attribute that we want to do as string. And then you could just say colon and then print. Here we could just say print and then get the name. We could just print it as only the C here, which is the character itself. So if we do that one, and then that would just type in those characters here. And then you can also create a string, say a string1 is equal, or just rather than string1, so let's say name is equal Wahidullah, and then say for a name n in name, and then you could say print n. Each character will be printed like that. But then if you say a name, it will print Wahidullah. Now that the method that are available for name is just all of them are right here. All the methods for this one. So if I say type of name, it is going to say is a string class. So it's a string class, and that means that these are a method that are available for string. All these double underscore magic method or for the string. So with the string, whatever you can do, you can type it a method like uppercase. So name is this. If you want to change it to uppercase, you say upper and then write it as method. That will change it to Wahidullah. If you want it lowercase, all of them, you say lower. And because there's a method lower somewhere here, then you can use that method. And then if it is not there, you cannot do it, but it is there. So here you could say title, give me the title, it will change it to like the first character there. And then if you say, let's say swap case, swap case. So whatever is the character, in this case W was uppercase, it changed it to lowercase, and everything else was lowercase, it changed it to uppercase. So a lot of the functions that are here, you can use them. I'm not gonna go through each one of them one by one, but they are available for you to do a string manipulation here. So at the same time, you can do a string concatenation. So a name is this, and now if I say name plus Lutfi, another string, it will concatenate them. But notice it does not give any space between them. If I want to give a space, I have to do this a space here. Or I could say last name is equal, and then say Lutfi, and then I could say print name, comma, last name. Since I put a comma, now it's going to automatically put a space between them when you do that. And you can also do a plus, but there's not going to be any space. So in order to do plus, you have to do a string here, whether you do a single quote or double quote, and then concatenate all of them, you can just do so, and then that would just do the same thing as comma. And then you can also use the f string function, f, and then say name within this, and then space, and then last name, and then you just do that. That would also print it like that. This f, whenever you use double quote, you have to close it with double quote. That's part of it. And now if I just want to say only that name should be dot title, dot uppercase maybe, dot uppercase, you could do this method, which is a concept of object-oriented. So the string dot method name, I will just change that one to uppercase. And then if you want to just add age to it, you could just say age, but age is not defined here. So you could just say a number like 59 or 100. It doesn't matter what number you put. So that's there. I hope I make it this 60, 70, whatever. So this is what it is sometimes. And you could just change this one to whatever number you want, and then that would do this. So, but age is equal, you could say age is equal, let's say 500, doesn't matter, 50. If you do 50, and then here, right, you could type in age, it's gonna just return that value. So type of age is an integer, and then you can see type of name is equal to string, and type of last name is also a string. So you cannot just say this and then say plus, because the one is a string, the other one is an integer. You cannot concatenate those ones. And you say cannot only concatenate string to string. So then you have to cast it like a string here, and then that would just write 50 and 50 and a string. So right here, you can see that I put a space here. So how you format it is up to you. You can do it, but then make sure that you're not concatenating a floating point with a string or an integer with a string or something. The same data type has to be concatenated. So if you say age plus age, that 50 plus 50, that's 100, it works. Or age times age it would work also. But if you say name plus name, then you're just adding the string together. You're concatenating it every time you do it. It's just the same word. So if W is equal W, and then you say W plus W, now you have two of them. If you want to do one more time, that's the three of them. But if you say W times 10, now you multiply that W 10 times. So in other words, if you say print new line character here, this is just going to do one new line character. And the print a new line character, it will just do. If you do two of them, it will just do two. So another fast way to clear your screen, you could just say times 50, like this. But notice that clear screen and the prompt stayed there on the bottom. So if I just run the command, it's going to show me here. But every time I do a clear screen, my command is still just showing what I wrote there. So let's do the dir here and then help command. And so if I just do something like help and then name, just that the string is there or dir of name, but I want to just clear the screen and move up to the top of the prompt. So instead of doing this, which is on the bottom, you could run the command here, dir of name. Let me just show you. So now you can say import OS module, and then dir of OS. OS has a method called system, and then that system, you could just use that one, dir of OS, and then clear the screen. Not dir. And then say os.system, and then clear the screen. And then clear the screen is a command on Windows like this, and then that would do it. So help on os.system, it's going to give you the system function. If you want to do it like this, it's going to say, I don't understand the command because you're just passing a function. The actual function is like this. So os.system, now if I just run the system command, hostname is going to give me the hostname. If I run the directory command, which are all the string output, and then you just get the output of the string. So with these objects, you can do a lot more to it. So for example, if I say os.hostname is going to do this one, but then if I want it all in uppercase, I could say, and then just right here, the method that is going to print, then I say, okay, so this is going to assign a variable to a variable. Let's say hostname is equal, and then say type edge, and I mean, sorry, dir of edge, and edge is already 0, assigned value of 0, rather than the other one. So instead of using this function, you want to use the process open function. So let me just say, clear the screen here one time, right here, and then I'm going to say a stream is equal. So I'm going to create a stream, and then I'm going to say os.process open, and then at this time I'm going to just run the hostname command, and then the hostname is output is there, and then now say output is equal, and then stream.read function. Now type of output is a string, and you can see dir of output, all the methods that were available for string, it is also available for that. So if I just say output dot upper, the same algorithm name is going to written in uppercase. But if I don't want to see the new line character, I use a print statement in front of it. And then when I want to clear the screen, os.system, It's already there. Last time we did it, and now output is still defined here, and you could do whatever you want to do with it. If you want to change it to lowercase, you could say, and instead of uppercase, to lowercase. So the methods that are available for a string is all available here. With a string, you could do a lot more stuff, and then a lot of names. Let's just do a couple of more strings. Actually, I'm going to quit out of this one, and then since I'm on the string method, more string one dot py. So and look at this one. I'm just showing you how to define a string called cake. A string foot sub 0 is pointing to the C, and foot sub 1 is pointing to the A, and foot sub 2 is pointing to the K, and so on. And then when you go and reverse, -1 is going to be returning E, -2 is going to return the second one, and so on, all of that. And then when you print this one, foot sub 0, it's got all of this. So if I just run this one, I could say Python string 1.py, and it will get the same output. This is how you run the Python program inside the idle or command line. Command line, you just give the name of the program, Python program, it will just load it. When you're inside the idle search engine, you just idle interpreter, you just do import the string 1. And similarly for string 2, so if I say type string 2.py, that one is another program, and the string 2 start from here, chapter 6 Python strings, and then now we're looking at I love playing soccer, and then play a sport, and then name of the sports. So to find the length of the string, you use the length, len, length function, and then it shows that one. Print each character in sequence. So now we're printing the character in sequence with the array element for each of those ones, and then using the for loop. This one was giving an example of while loop, and this is example of for loop. And then now if I just run the same code, the same Python, you can see that it is giving the same output. The first one says the length is there, but I love playing soccer was the output, and then so on. All of that one, I'm going to just say, let's just open it on the code here. So I already have installed Visual Studio Code. All I have to do is type code. And then notice that it opens the directory where I want. So if I just don't know what it is, I could just go on this directory here, and then say directory string 1.py. I could do code string 1.py if I want to open string 1.py. And then right here, everything is already loaded. You can see that one. I can run it here, and it will just run it from there. And then run code or run Python program, and then click on it. As well as you have the option of under the setting, you have, if you have done the terminals already, it just already, you can see it is coming for that one, and the output is showing and right here. So let me close these ones. And if I just move up this one, you can see on the terminal to find the link. You just get that one and everything else. At the same time, if you're on this directory and you go to programs, cd to demo, clear screen, and then here we say we have a programs, and then Python. You can go to that directory and then go to chapter 6 on this one, and then now do a dir on the string 1.py, you have that program. You can also run it from here, string 1.py, and you will get the output here the same way that you get it from the command line. So this is with Visual Studio Code. If you run this one and you just don't want to open one of them, you could say code dot, it will just run the same program, it opens all of them in the list, and then you can close this welcome page here. Now, string 1 is one of them that we showed you in the string. Then you can click on string 2, and then string 2 is this code there. And then same thing with the string 3. So the only thing with the string is that is important is that it's not a one character, it's more than 2 characters along, and they are indexed by each element. So like you can see that you can count, do the count to find out how many T's are there, how many uppercase T or lowercase in that string message. So you could just go through it and then run the program. Similarly, for the string ordinary, if you want to get ordinary of A, then you run this one, and if you want to get the character of A, you just use the char 65, and then you get the character value. And then this is more for statement with all of that. And I'm going to close this one. And you could just, as an example, it's much easier to show you on a bigger screen. String 2.py, you can see the output right here. And then more on string 2.py. String 2.py, you can see the code here, all of it. And then similarly for string 3.py, more string 3.py, you can see that here we're counting it, and then for the message, we go through the count, and then if you run the code, say Python string 3.py, it should give you the count on all of those ones. So T is 1 time it happened, and lowercase is 4 times, S is 5 times, and is 4 times, and Z is not happening at all because that string does not have any Z. So it is very simple, very efficient. It goes through this for statement and then increment the count as it finds the character in it, and then that's how that code works. So the next one I'm going to show you string star. Okay, the 4, I believe. Okay, we didn't do 4, and let's see what's inside the 4. 4 is this more string 4.py, and notice that the string 4, I told you ordinary of A is going to print the character A, and then character 65 is going to give you A. So let's see, ordinary of A is going to give you 65 and a number, and then character of 65 is going to give you A. So when you run it, and also at some point I went to the range for statement with all the way to 256 different characters, and you heard the bell sound. At some point there was a bell sound, and when you run this one, it will just do the bell sound. You can see somewhere it is a bell sound, maybe the number 7, I believe it is on this one, but ordinary should be on the top one, and the first 2 character. Let's see, right somewhere, these are all the decimal value, all the non-ASCII characters, 256. Since I'm doing it twice on the loop, there's a larger number, but you can see here, ordinary of A is 65 and character of 65 is 8. So that's how the interpretation. Then it goes through the for statement for each one of them, and it prints all those characters with their ASCII number associated, the result. And then this is for the string, so we're done with the string. We're gonna jump into chapter 6, chapter 7 in this case, chapter 7, and then look at the directory of star.py. At this time, there's a number of them, and some of these ones are file IO, and other ones. I'm going to, since I'm on the chapter 7, I'm going to cover a very quick example of Simba.py. This was my favorite cat, that we had a very beautiful cat. So there's a name of it, Simba.jpg. So if I say start Simba.jpg, this beautiful cat was our Simba, and then I don't know where it is at this time. After a while, it left, and then it was very sad for us at that time, and he could just not stay for whatever reason to him at that time that was emotional for me and for him, and then he left and couldn't come back. And I don't know if somebody took it or an animal took him. He was very, very brave and very nice animal, and it was very smart at the same time. I loved him, and he loved us too. Unfortunately, we don't have him anymore. So Simba is the program here. I'm opening using open statement to read in binary and the file simba.jpg as file descriptor. Then I open the Simba underscore copy, and then I make a copy of this file by writing it in binary backward onto the file descriptor. So every time I read one byte, and then I write that byte, as long as that byte is not, the file is not read all the way to the end, I'll read it, and then eventually I close the file because I have used the with statement. The file descriptor file manager of Python automatically closes it. There's no file descriptor.close statement, because when you use with, the file manager take care of it for you, the context manager of the Python. So at this time, once it loses the context on that file, it closes it safely for you, gracefully. So now, if I just look at Simba store, there's a copy already. I'm gonna delete this copy, so we know that I don't have a .jpg copy. And then now we look at the same statement, we only have that one. So now if I run the Python Simba.py, it will just make a copy of it. Now I do have a copy for it, and as of today, you can see it's 1229. If I run date/t, you can see it as 1229. We are running this command on Windows platform, so you have to know that your commands like directory and other ones. Now, if I want to open the Simba copy that I made, I want to get the copy of it, same thing that I had seen that one. So byte by byte, we use that code. And this is the code, type Simba.py. This is very small line of code, and then it opens the file in binary and writes it back in binary, and automatically close it when it's written, and now you have a copy. It's almost like, say, copy Simba.jpg to w.jpg. Now I have w.jpg is the same one. So if I just say start that one, that's our operating system copy, but we did it through the Python. So now I don't need the w.jpg, I delete it. Okay, so this is just an example of other ones. Although I have more examples of soccer and other ones with the file IO, but that would be when we cover file IO and maybe modules and reading files and writing files and images and graphic and paints, and then I'll cover those ones. So let's go to chapter 8. CD in chapter 8. And on chapter 8, I have a number of examples, but these are all for Python and less than other ones. So example 3, example 4, 5, 6, list comprehension, list example 1 through 5, and then list examples, and check on list .py. There's a number of them, py5.py, t1.py. So let's go to first ex.py. see how many of them are there. More example 3.py. And then this example, I'm just going through a while statement. It does a try an exception. So it says that while it's this one is this. This is not list. This is not any of them. So I'm not going to cover this one. It's a while statement with try exception. Let's do the example 4. See what it is that one about. OS module, clear screen, POSIX. Yeah, these are all other modules that I might have covered it on previous session. I'm gonna just go through the other examples. So list 1 through list 5, and then the list comprehension. So directory list to start. This is for list. I'm going to cover everything on list. Notice I had done this one with a PDF file, also a doc that I wrote, and then I generated a PDF file. So let me just open it on this. I will give you a quick overview of list examples that I covered at the time. List one example.py source code. So this is for the source code of the one, and the class that I taught was 10/01/2020, about 3 years ago. So declare a simple list and call it list one. So this is going to just generate a clear list one, and then assign these elements to it. Element sub 0 is 1, and sub 1 is 2, and the last one is banana, and so on. The original list is list 1. I'm printing it here. And then for item and list, I go through a for statement. I get the length of the list, and then as I pop each element from the list, I show the output here, and then here the output of the Python example. And so I pop each element, and then eventually the list is empty. This is a list example 2 that is there, and the output is here. But let me just quickly show you this. You're welcome to just stop the video and look at it in more detail, but I'm going to show you inside Python rather than on the PDF file. Because a lot of the lectures people show you on the PDF file, but if you just don't memorize it, you will not understand it. And you don't know why you did that one, or how did you sort it, and how you do all of that one or here. So let me just minimize this one, come back here. And then the first thing I'm going to do is say, let's run PyCharm. So I'm gonna run PyCharm, and instead of Visual Studio Code, I'm gonna open this one in the PyCharm. And I'm gonna say list example 1.py. Whenever you give the name of the program Python, is supposed to open it for you. And then do not ask again, open in project. Open in project, so this is the list one. It is opening it already for me. And I can just say, okay, this is the list. And I can also come here on the main, and then let's see if I close this one, and I just give it like this without any name of the source code. This is opening PyCharm. So notice that this is now the interface is the whole thing. I'm on chapter 7, but I could go on chapter 8, I believe. On the directory, I was on chapter 8, I believe. Let me close this one to make sure I was in chapter 8. Yeah, chapter 8. So clear screen and then run the PyCharm. I'm on chapter 8, and then on chapter 8, if I just change this one to chapter 6, 7, let's say open, and then I go to chapter 8, double click here, and then new project. Let's see why it didn't open chapter 8. Context. Close. Python, PyCharm. When you put a dot, it's supposed to open the current chapter with chapter 8. So on the command line, I put the PyCharm dot, and then it automatically opened chapter 8 for me. And then now I have the example. So if I double click here, it's going to open PyCharm. And this is the list comprehension for, I mean, this is just a list, not list comprehension. And it's creating this list, and then it's executing all of these things, giving you output and everything. And then you can also run it from the terminal here. So one way to do it from the terminal, if you see this run here, you can run the Python program, and then you see here's the output here. So it ran the example 1.py, and it shows the original output here, and then all of the detail here. At the same time, if you just say, well, since it's the command prompt here, the terminal here, you could also run it from the command line here. There of list list start of example, and then there of list example 1.py is that program, and instead of there, if you just say Python, then it's going to run it. And you can resize this window here to just see more output here. So this was the output, and when you do that there, it gives you that output. When you just run it exactly, it will just give you this output. The length of the list is 2, and the value are there. Similarly, if I just say type list 2, list, what is the example? List example, type list example 2.py, it will show the same thing here. And then that would be the output of it. And then I could just also run it. Okay, so I'm going to just give you some examples rather than on the IDE here. I'm going to just close the PyCharm here, and then show you some more examples on the command line, because it's much bigger and then nicer looking on the blue screen, and you can see everything clearly, so you don't have to just have problem with your eyes. So clear screen here. I'm going to say Python here, and now I'm going to create a list. So to create a list, you just say list 1 is equal, and then you just give elements 1, 2, 3, 4, 5, and let's say you assign true value, false value, and then another list. You could do list within list, and say 6, 7, 8, and then let's say a string value, say Wahidullah. Wahid is good enough, and then I'm gonna just say MyWebUniversity, and then you could do as many as you want, but L1 is now is a list. Type of L1 is already showing you it's a list. And so there of L1, you can see that you have created a list with this. These are the methods that are available. So if you say for L and L1, print F, and then say, let's just print the type of it, say type of L. We're going to get the type of it, and then also type of L, and as well as we want to do the L itself is which is whatever it is the value for it. We want to get that and then close it, and close this. So notice that for each of the element, we say the data type is integer, or the data type is a string, as a list, or a boolean, or a string, or a string. So you could get all the elements that way too. L is the list. For example, L1 is the entire list. L sub 0 is going to give you the first element, which is a 1. And then L sub whatever this one is 2. Okay, let's say 0, 1, 2, 3, 4, 5, 6, 6. So this one is a list, 7. So if I say L1 sub 7, I'm going to get the entire list. If I want to get an element of that one, then I could print out 1 that would print out 7. That's how you do it. 2 is the 8. And 0 is the first one, 6. So this is how you reference those elements. At the same time, L8 would print out Wahid. L9 would be MyWebUniversity. Also, -1 would also print MyWebUniversity. -2 would be printing Wahid, and so on. So for element, we could do that one with the list. Now, the type of the list, each one of them, certain methods are available. When it is integer, you can add up and do things with it. When it is a string, you cannot do anything with it. Like, for example, you can only do a string manipulation that is allowed, the method that are available for a string. Like this one is returning Wahid. You can say, for example, upper, that method is going to change it to Wahid. And then if you do it for sub-0, and sub-0 is an integer, you cannot do to upper because that is only a 1. So you can do it times 10 and do multiplication on it. Or times 25, it's going to say 25. Whatever you do is, or say import math module, say math dot square root of let's say 100 is going to just return 100 at 10. Now you can say math dot pow and then 2 to the power of that. So that's 2 is this, and then now you're getting to the power of 10, which is 1024. It's like saying power of 2 to the power of 10. And that is also doing that. Or math.pow, that one is also going to do the same thing. Pow is a function within math module as well as a standard method on Python. So if you do something like this, remember that L1 sub 2 is pointing to number 3. So now if you say L1 sub 2 and you say math.pow, and then here you could say 10, now you get 1000 because that, I'm sorry, 3 to the power of that. But we want to not get that. We want to say 3 to the power of 3 times 3. That would be 3 was there, that's 27. Yeah, you could get something like that. And then you can do whatever manipulation you want. It's those are available for you. So the list has also list comprehension. So list, you can also do import sys, and you could say sys.getsizeof, and then L1. Now L1 is 136 bytes long. So if I say help on sys.getsizeof, you can see that method, that attribute or property, that attribute is saying that it returns an integer, the size in bytes. So when you declare a list, it has L1 has a lot of overhead because it's not only one data type like string or integer, and that is defined in C, C++, Java, and other ones. So when you declare them, the array is homogeneous on C and C++ and Java. But in less than Python, these are just heterogeneous. meaning that you have integers, true, false, other list, you have floating points, you have strings, and all kind of other attributes. So while you can have defined multiple different data types on the same list, on the array, it is only one type. That's why it is very fast. So NumPy module was written in C for that purpose, to just get rid of the overhead and that the list does and list comprehension does with multiple different data types. There's a lot of overhead on it. So if you compare a list with tuple, tuple is much faster and much more efficient and is immutable. It's a list, you can change the elements. So for example, L sub 1, you can say is pointing to 2, and you can say assign this one to a string called Lutfi. You can do that one. Now L sub 1 is going to return that. Type of L sub 1 now is a string, L sub 1. That is a string rather than an integer. And if you change that one to say, let's say get 5.5, it's a floating point. Now you can type it as a float. If you just change it to a 5, let's say a 5, it's an integer. Now a type of it is integer. So with that, the type of, instead of dir, you could do a dir. You see that the elements that are available for an integer is a lot different than a float, than a lot different for a string, and so on. So the get size of is another thing that when you do, L1 is there. Now, if I just want to insert another method, another list into it, I can add it another string, I could do it. So I could say L1.insert, and then if I want to insert on the first element and say another Wahid, I could just enter it, and then that would just L1 is now 2 Wahid there. So duplication is allowed on the list, but not on the set. In order for me to make this one a set, let's insert another one, append. And instead of L1, I'm going to say L1.insert, I'm going to say append. And then now I could just add the Wahid at the end of it also. So now I have Wahid here, Wahid here, Wahid here. And then if I just want to insert a number like 5, or just let's say 4, the number 4, now L1 has 1, 4 also. Notice that the 4 is here, and there's also at the end of it. Because I use the append, add at the end. Append means put it on the end of it. Now if I say L1.pop, it will just pop the last element, the 4. So L1 now is not having a 4. If I do a pop one more time, and then it's Wahid is also out. So L1 now is this string. It has 2 Wahid, and then if I just insert that 4 back again, let's say right here, L1 now has the 4 after MyWebUniversity. So there's 2 string Wahid and then 2 number 4. But if I just change that one to set1 is equal set, and then I just say L1, then sorry, lowercase set, let me see what I did that. S1 is equal set L1. Name set is not defined. Did you mean set? Yeah, I thought it was lowercase and hashable type list. Okay, so the list itself, this one is not hashable. Whatever is that means, because of the list is a combination of so many things, and not integer or one data type or string or something. So L1 is this. If I just say, okay, let's do L2 is equal, I'm gonna just say L1 sub 1 colon. So this is 1, 2, 3, 4, 5. I want to get those if I do 6, it's going to include and the last one also, and then L2 now has those numbers. L2 is the list. Now if I just insert, the 5 is already duplicated twice here. So now if I say S1 is equal set, and then L2 and is also not doing it, lowercase. Yeah, lowercase is the set, because set, when you do it like less than other ones, or set is lowercase. So type of set, now type of S1, you can see it's a set. S1 is now no duplication on, but L2 it has duplication. And so a list allows you duplicate, but a set does not. So in order to get rid of that duplication, you can do that one. Also, S1 now is this one. Dir of S1, you can see a lot of methods are available. Dir of S1 is a lot of methods are available. So S1.union, S1. So if I just have S1 this, let's just do S2 is equal. We create a set, and when you create set, it's like this. This brace 1 and then 3. So let's just do those ones. S1 is this, and S2 is only 1 and 3. Now if I say S1 dot union of S2, and the union of them or all the numbers that are included in both. But if I want an intersection of that one, then only what is not in both, what is common in both actually, and the intersection of them. So you can see all these methods and other ones that are available. You can play around with them and practice them. But I want to show you the difference between list and tuple. So I say tuple is mutable. Let me say I'm gonna just do import OS and then say os.system. I'm gonna say clear screen here, and then I'm going to say L1 is this, and then at this time I want to just define L1 only, maybe 0 through let's do through 5, 6. So I'm gonna say L3. Another list is I'm gonna say L1 sub 0 all the way to 7. And let's see what we get on that one is we're gonna get 0, 1, 2, 3, 4, 5, 6. 6 is this one, and then the last one, 7, is not included, so we get that value. And then if I just say, well, that is a list, type of L3 is a list, and then we have the list there. I want to just generate same list as a tuple. So I'm going to say T3 for a tuple, and I'm going to just do tuple here, and then I'm going to put these elements in there, and then close it there. You don't have to type in tuple here. When you do the brace, this is going to define that T3 as a tuple, and T3 is there as tuple. So if I do a dir of T3, notice the number of methods that are available for tuple is much smaller. Aside from all those double underscore magic method, there's only a few of these one, count and index or what is available on it. So the length of the tuple, it give you the function length is available for both of them. So length of T3 and L3 is the same length, 7 elements. So L3 is that, and T3 is that. So L3 0 cut to 7 will also return the same thing, and then T3 also give you the same thing. So similar methods are available. However, when you do import a sys module, there's a sys.getsizeof method. Now, if you do a L3 for less, you can see it is much larger in bytes. And then I told you that it is a lot of overhead on it. And notice that T3 is less in terms of byte for storage, storing the same data type. Another thing that you're doing on this one, if you say dir of L3 versus dir of T3, notice that dir of L3 is a lot of methods are available. So you can just copy a list, you can count them, you can extend it, you can get index of it, you can insert it, you can modify it, update it, delete it, everything. With the list, with the list you can do all the changes. But with tuple, they're immutable, meaning that you cannot reassign a value for it. It is read only. Once you assign it, like for example, math.py, it is 3.14, some large number of zeros in floating point numbers, whatever, 3.14 or something. Like if I say math, import math.py, you can see it's a very large number after 3.14. So all of those numbers are just showing. You can also decide how many characters you want to print and how many digits you want to show in the format of the F string output. But that is beside this class. I'm going to right now talk about the difference between list and tuple. So one difference between list and tuple is the size of that I showed you. T3 dot I'm sorry, sys.get size of, and then T3 that shows you 96 bytes, but L3 shows you much larger size. So if you look at that one in terms of the differences, so at this time I'm going to show you the sys.getsizeof for both of them, and then you can see list has more number of bytes, the overhead. L3 is this, and T3 is that. So even though they're the same, one is tuple, T3, and L is list data structure. So at this time, if I just want to run these codes, I could run them also by doing something like import time it. So once you import time it, I could say, for example, L3, maybe L3, and then give some kind of result in terms of or a number and floating point number, float number. I'm gonna just say if I just do time it dot that module dot time it function method, and then the first one is a statement is equal, and then I'm going to put within code this list. This will just show the list one, and then also a number. Let's just run it 5 million, really huge. So 5000. In Python, you can do underscore, so you can see that the number of 6 zeros separated by underscore, that will allow it. And now type of L3 underscore a floating number, you can see that one is a floating value, and that we got an output for that one. So if I just say L3 floating point number, it took 0.21 second for the list. If I do the same thing for the argument and just change it to a tuple, T3 floating point number, and then just change this one to a tuple in the state of a list, and then all the other arguments are the same. So the same size of the list, same elements, everything being the same. Now, if I run T3 underscore floating point number, notice how small this one is. The other one was 21 seconds, this one is 0.04, which is that there's not that many overhead. For 5 million object, it took this much in nanosecond versus 21 second here. So that is how they differ on it. And then of course, type of T3 underscore floating point number is also a floating point value. So you can see that one. And then the reason was this, remember that dir of T3 versus dir of L3. And there's more methods are available, more overhead, more stuff. And then when you do 5 million times, it adds up in terms of how many bytes it takes and how many things is going to do, how much and performance, how much is going to differ. So that is for the tuple, and then the list. For tuple, you can also, like if I just say T3, you cannot say T3 sub 0. You can get the output from it, read it, but you cannot change it. You cannot say this one, change it to a Hidala or something. You cannot do that. It says it's immutable. So you cannot, sorry, I have to do single quote, and it will say tuple does not support assignment statement. And the same thing with tuple, the elements cannot be changed, but you can iterate through T for T and T3. You can print each element separately, and you can do that one. That's not a problem. You can see here. And similarly for L and L3, if you want to just go to iterate those ones, print L, you could do that one. And similarly, if you just do the data type, you say for L and L3, and let's just do print F and then say, sorry, F and then here we say L, a type of it first. We want to print the type of L, and then also print the element of L. So we get both of them, and that would just say the first one is a string, the value is Wahid, and so on. And that's for the data type there, string and everything. Similarly, if you want to do for the tuple, you just do this T and then this one T3, and then this other element instead of this one, just do T and then T here, and you could see that similarly there. So list comprehension is also very useful. Let's do a list comprehension. You could say X is equal, and then you could say X for X and range of let's say 100, and then that will just do this 0 to 99. And if you say let's just say if X module 2 is module 2 is equal 0, then get that value. Now all the even numbers will be printed. Similarly, if I just say not equals 0, all the odd numbers are going to be printed. Similarly, I could do multiplication on them. So for example, if I just say this one, start from 10 and then do 100, and then increment of 20, now X is a smaller list. So if I just say whatever is the number, multiply it by itself, then you can just do in the list comprehension like lambda function. If you do X times X, then 10 times 10, 30 times 30, and so on, 90 times 90. So it will just be that. And if you just do a power of, you could just say this one is going to give way huge. Now it is there. The last number is really huge. The first number, x to 10 to the power of 10, is this number. The next number was 90, 30, 30 to the power of 30 is this. The last number is this huge number that starts right here. 99 whatever it was, 90 to the power. So if I say 90 to the power of 90, then I get that last element. Starting with that 76 here, similarly here. Or I could also do how of 90 and then comma 90. We'll just do the same thing. So this is how list comprehension is very useful. Similar to the list comprehension, you have tuple comprehension. So with the tuple comprehension, the only difference is that if you just do this, the list comprehension, let's say x to the power of 2, and then x is now those elements. 10 to the power of 2 is 100, and 90 is to the power of 2 is whatever is that, 30 to the power of 2 is 900, and so on. All of that one will be done, but if you just don't multiply it, you just get this and then access all that. So you can print out those ones. And then if you just there's list addition and multiplication. So let's say one list we define with list x1, another one with x2, x2. So x1 is this, x2 is this. Now you can do x1 times x2. This one will just say it's a problem. But when you do addition, you will add list concatenated next to each other. Multiplication is not allowed like this, but you can use NumPy module to do that one. With NumPy module, you could just create a NumPy. So you could say import NumPy as NP. Watch my other videos on NumPy and other ones. Import NumPy as NP, and then you see np.array, and then let's say we call it A is equal a list, and say np.array, and then we could say x1, and now A is a list of an array of that one. So now you say 8 times 10, it will just do multiplication on that element there. Or you could say B is equal np.array. This is like matrix multiplication. X2, and now one more right here. B is there, so A is this, and then if you want to just numpy.info of A, you could get all the elements of it. Similarly, of B, you get all the elements. A is this, and then A.number of dimension is going to return one dimension array, and then B.one dimension. Since they are the same dimension, you could say A times B, and you will do multiplication on it. A is this, and B is this, but 10 times 100 is going to go 1,000. 30 times 900 is 2,700. And the last two elements, 90 in this, is going to give you a larger number there. And so 90 times 81 is going to give you that. So this is how you cannot do multiplication on the list, but you can do on NumPy, because they are same data type and they have to be same size and everything, number of dimension. And so with tuple, I want to show you similar to the list. You can also create a tuple. So if I say tuple 1 is equal, and then I could say x and for x and then I could say a list of tuples of 1, 2, 3, 4. Let's say I do that, and then I say T1. Now type of T1, this is just not a tuple, it's an iterator, a generator. So in order to do that one, I could just do this one and just say tuple here. And then now, actually not here, I could just say do this and then do this tuple here, tuple, and then return that plus this, and then T1 now is a tuple 1, 2, 3, 4, and type of T1 you can see it is a tuple versus a generator. Since we say that create this as a list or as a set, and I mean as a generator, then convert it to a tuple. Now this tuple. With tuple, when you just say T1 is equal 1, and this is just a number. Even though you name it as T1, it is not a tuple, it's an integer. But if you say T1 comma here, now it is a tuple. Because this comma, even though you could have done this something like this, if you just do T1 is equal, and then you use one element in it, this is not a tuple either. Watch this one, it is an integer. If you did this one within a code, it is now T1 is a string. So be careful on that one. What you mean is that you want to just create a tuple, you have to put a comma here, then now T1 is a tuple. This is how a tuple is there. There has to be more than one element. A tuple was separated by comma. And then for the list, we already talked about it in the list comprehension. We talked about it, tuple comprehension. We talked about it. Let's go to the next chapter, which is maybe data dictionary or chapter 9. Let's go to 9. Chapter 9 is data dictionary. So start the pie here. We have D1, D3, D. So more dictionary 1.5. And then you can see here the dictionary. We are creating capitals as dictionary. And then the dictionary has a hash and key. The key pair value. The key is capital of Afghanistan is Kabul. Capital of France is Paris, and the capital of Switzerland, Bern, and so on. So when you go to this list of capitals, notice the hash and key, and instead of a number, the hash key is a unique key. You cannot have one country named Afghanistan and the second country matching exactly string Afghanistan. It has to be different. If you have it uppercase, lowercase, it is different. But make sure that the key is always unique, the key pair value, and assign that value to it. So when you declare a dictionary, you can declare empty dictionary like this, or you could just create the dictionary and assign elements to it. So capital is done. Now these are elements that you do it. Every time you add to the element, you do a key and a value pair. And then when you call it the countries, whenever you just get a list of countries, this is a list of all the countries. This is a list, and then maybe there's another list that could be capitals. We could do it. So now for countries and countries, do if country is in capital, the capital of country is that. So it is a very simple program. I'm going to run it. Python. You can see that the capital of Afghanistan is Kabul, the capital of Russia is Moscow, France is Paris, USA is Washington, Switzerland is burned, Japan is unknown, China is unknown. If you did not define the thing, it will just go to that country because we didn't assign anything for that country. China is on the list, but it is not assigned here. So in order for China to have another the capital name here, did you just have to assign it value for it. So directory store.py and then dictionary 3 and 2.py, more dictionary 2.py. You can see here first name is assigned to Wahid, last name Lutfi, title is instructor, and favorite sport is football or soccer. And then it's good prints my dictionary, and my dictionary is going to give my information. And then add item, if I want to add the address, diamond bar, and then output is my dictionary, update. After updating the favorite sport and soccer, then instead of favorite sport, saying football, then I print it out the second time, it's going to be printing it with soccer. So now if I run this one, Python, you can see that the first one, it says this is the record. And then after updating it from the favorite sport to soccer, now it's soccer instead of football. So that's how that code is. And then I'm going to do a JupyterLab because I showed you on the video that I'm going to cover that one also. On JupyterLab, you can just use these methods here. You can just do whatever you want. If you do here, you could say, let's say commands is equal, and then we could just say, let's do import OS first. Import OS. I'm going to do a number of things. So say for commands is equal, I'm going to run a couple of commands here. And then I'm going to say run the host name as a list, host name, and then run the calculator. Calc command, and then maybe a notepad. Notepad, these are Windows commands that we want to do, and then say for CMD and commands, the list commands, and then we say stream is equal os dot process open, pipe open, and then I'm going to run the command method here, and then say output is equal stream dot read. So we read it, and then here say print f, and the command is, and then cmd output is, and then output. As simple as that. We have the code here, and then so when I run this Python program, and the cell module is going to import the OS module, then it declare a list which is a name is commands. It has this 3 commands in it. Host name sub-0 is command sub-0, and calc is command sub-1 is calc, and command sub-2 is notepad. And then we go through a for statement, and each one of them we run the command, and we should get the output here. So if I just go here and say run it in JupyterLab, it failed. The output here, I mistyped it here. I just want to say output, and that is corrected, I believe. This is whatever you define it here, you just have to call it there. And then now I'm going to run it, and it's going to run that. So the notepad is run, and then the scientific calculator is happening, and then the command output, and the host name is algorithm. So all of that one run, but this was an example of a list example we created running some commands here. If I just have one command, say run the directory command here, and then another command is date command, d/t. Then now I run the same code. Notice this time the output is different. So the command directory is right here, showing, and the date command is showing here, and that is there. So it is very, very intuitive with this, how you do it. And then you can also have the same code here running it from this. So notice this is Python 3. On the JupyterLab, you have console. You can go to the console and you can just click on this one. Now you have a console session open here. But if you want to just run, let's say, for example, terminal, this is on Windows, it's going to open a PowerShell. Since I'm on the directory of chapter 9, I can clear screen and say, and show me directory start.py. I could say start, not a start, a Python dictionary 3.py, whatever is that code, it's going to run and it's going to give me the output of it. Similarly, the dictionary 2.py was the example that we were seeing, and dictionary 2.py, let me just see, there store.py. So dictionary 2.py has a T here. So that's the output that we were looking at, the example football conversion there. So you can get that one as well. If you want to see the dictionary 3.py, and then you just say the content of it, I want to see it more, and it says that, okay, create an empty dictionary here, then it assigns these values for it, and then append to the dictionary and with the string and all of that elements, dictionary dot get value dot keys will dictionary dot keys will just show you all the keys, and dictionary dot value will show all the values. Dictionary dot items is going through the key pair values, and then you have to just actually, when you do that one, the key and then value. So you could just get that one. And let me just show you from the command line here. You can even run the code here on the dictionary there. So it was dictionary 3, I could say Python, and now I'm inside a Python, I could say import dictionary 3, and now I have the code here. And then when I do a dir, now notice dictionary 3 is here. Dir of dictionary 3 is going to show that all the elements there. So one of them is the dictionary 1, dictionary 2. Let's see, I'm going to say print dictionary 3 dot dictionary 2, for example, and you can see these are the key value. So if I say for a key comma value and dictionary 3 dot dictionary 2 print key and value. So now I'm going to get the key and value dictionary 3. Somehow dictionary 3 is not there with the DTD, so I have to run, for this no T here, and then do this, and now, let me just do a dir here first, dir of all of them, and dir of dictionary 3. So in dictionary 3, and then dictionary 3 dot d2 is going to give me that. So for key comma value and dictionary 3 dot dictionary 2 dot item. So now I have to get each item, and then I say print key comma value, and now I see them. Dictionary, oh, I mistyped it again. There's no T here, no T here. You have to type it based on what it is. Let me just get out of here, exit out of this one. I just might have typed it wrong on the names. So I'm going to clear screen, type dictionary 3.py. And then I just want to do one of the example. like this one. No, key pair value, right here. What is this one? Is key value dictionary one. So where did I define dictionary one is K and zip. Dictionary one, I'm going to look at this. Okay, so it's a lot of information. Let me just show you quickly by just creating it there. I could say Python, and then I say um, dictionary one, D1 is equal. I'm gonna say a dictionary, say for example, name, name, and then a string, and then say Wahid. And then just a key pair value I want to show you here. So and then the next one is age, and then colon, and then say 59. So that's what my age is at this time. So I'm gonna just say this, and then only those two elements is good enough. D1 dot keys, D1 dot keys is going to show you the keys. D1 dot values is going to show you the value for it, and D1 dot item dot items is going to dot items is going to show the key pair value. So for each of them, you could say for key comma value and D1 dot items, and then you could say print k comma value and separate it, and these ones it will show that. This is what I wanted to do that. On the other example, there's a lot of them, and the naming, I didn't want to type DICT3 when I meant DIC3. So we showed you the dictionary also example. There's a lot more example on the this.py. So dictionary 2.py. Let me just see what is d.py. This one is a dictionary capital Afghanistan. We went through that one already. But if we didn't, you could just say Python d.py, and it will just run the same output. On the top, we get all the values, and on the bottom, I run the help on it. That's why it is there. So more d.py. You can see here, this is the values that are doing it. At the end, I'm also getting some kind of they're on the directory of the dictionary, and then also capitals of Get India. So let's see what other things that we need. And there's some PDF file also. I have it. If you open, like for example, data dictionary, dictionary comprehension, you also will see what I did with the dictionary comprehension, copy and then paste. And if you are looking for inside this one, you open it. Sometimes it says, do you have permission? It did not have it because I'm on the terminal. But if I go here and just open another tab and then go to, let me just go exit out of here. I'm gonna just open another command prompt. Command prompt and say cd to / cd to demo programs. Let's go programs, and then Python, and then chapter 9, I believe it was the dictionary. .py, yeah. So I could have said directly start at PDF and then start a dictionary comprehension, this one. And then since that's a DOS command prompt, it will open the dictionary, and this is Python dictionary with that examples of printing keys and values and items and each one of them. So you're welcome to practice them. And if you need more reference, you could just come back here on the documentation on Python. For all of the things that I showed you here, you can come up on python.org, and then under documentation or docs, if you click on docs, you have the library reference as well as language reference as well as tutorial. So if you look at the language reference, you can search for all of the string, list, tuples, class, and everything. And if you're looking for class definition, for example, it gives you the class definition. I did not cover the object-oriented yet. I want to just make sure that you understand object-oriented is very detailed. I'm going to cover that one on a separate video. I have already covered a lot of object-oriented with Python on these videos. So you're welcome to look at my previous videos. Basically, object-oriented programming, I showed you some of the methods and attributes already with object-oriented. Python is both functional programming as well as object-oriented programming. And with object-oriented, basically, you have objects and classes. Object, an instance of a class is a blueprint of kind of a object. So for example, if a human being is the class, then we are all example of human being, an instance of human being. We have certain attributes, the height, the width, the age, the color of the skin, the name, everything is our attributes or properties. And the things that we can do as a function, we can walk, we can talk, we can write, we can play soccer, we can read, we can teach. All of those ones are methods that are associated to object. So a car is a kind of automobile is a type of class, and then every model that is different, Toyota, BMW, Camry, Mercedes, all of them are different type of that object, different object of that type class, car. And then similarly with furniture, similarly for employees, each one of them. So for example, employee is the class, and then full-time employee is an example of an instance that they inherit something from the superclass, which is employee. Each one of them has names and salary and all those kind of job title. They inherit from the parent class and so on. So on object-oriented programming, there's a lot of concept of four paradigms, basically. The four paradigms are encapsulation, polymorphisms, data abstraction, or and then inheritance, and encapsulation and polymorphisms. Polymorphism means multiple form. Encapsulation is putting the data into a capsule, protected in other classes that you do, subclasses and public classes. And then you can also do inheritance, which the child inherit the parent class, and then superclass and subclasses, all of those ones. Polymorphism is like, for example, let me show you an example of a polymorphism here. Let's go to chapter 14. Chapter 14, we have a number of PDF file also. You can look at those ones, like for example, start pet.pdf. This is just for pet class. You define a pet class here as a pet class. You can use the left parentheses, right parentheses, but it's not required. You could put colon is there. This is a constructor in C++. We call it instantiation or constructor to initialize the class name. So every time you call the pet class, then it calls the instantiation or constructor. And then self is by itself is pointing to the object itself. Name is one of the attribute of the object, the instance. Age is another attribute, color is another attribute. So you say self.name is equal name, self.age is age, self.color is equal color. And then these are the functions that are for the object. So whenever you use that self, you're talking about the object. Whenever you're using CLS for class, then you're defining the class attribute or methods. So for here, we are returning I'm this, and then I'm that many years old, and then my color is that. So this function display will do that one for that object whenever you call it. And then now we have get name to return the name of the object, and then speak. By default, if all the animals they want to speak, then they say don't know what to say. But when it comes to dog, then they bark. The speak is bark. And when it comes to cat, it says meow. So the cat has the method meow here, and the dog does the bark. So for the speak method, depending on different object, that gets a different form. That's what polymorphism is. So the same method, whatever the object is, it gets a different method and react differently based on that. And then we are going to discuss these ones on details, but please understand that in one video that would be too long for this one, and please watch my other videos on the subject that I've already covered. Also use these one as reference. And so when you're on these subjects, if you look at the tutorials, there's a lot of stuff with the numbers, text, and list. And when you do this one, sometimes it defines the list and give you examples, and then a lot of the different type of examples. I covered append and other ones, but you can do list comprehension and all of that one somewhere here. And if you say, for example, for the string text, you can see that the text or a string is the same. But you can also on this one, and when you go here, you can say Control F and then say, for example, tuple. Search for tuple. Let's see, tuple. It's not there, but a string. And then a string is there, so you could search for a string and find it. And then obviously, when you go to this definition here, you can just go under language reference, and then under language reference, Control F and say tuple. I'm sorry, tuple, and then you will not find tuple. Okay, string list. Yeah, list is detailed, but it does show when you go on those ones. At some point, you will get information about them. Let me see under reference. Class. Yeah, class is there, and let's see if there's all kind of information. Tuple. Yeah, under the language reference section, you will see the tuple. So you can click on this one, and you will see the tuple. All the details are there. And every elements, whatever you can do with them, and they're there. I hope you enjoyed this video. I'm going to and just end this video for this one. I hope you subscribe the channel, watch the other videos that I've already made for Python related stuff in terms of data structure and NumPy and maybe modules and maybe a list, set, and tuples and data dictionary. I've made a lot of videos on it. It's already there, so just search for them, and if you just do like Python, there's all kind of videos that are coming here. You can see them, and then PyDoc import the keywords. And so if I just say, for example, tuple, then let's see if the videos, yeah, Python and directive tuple data structure. So watch that video. There's a tuple data structure. Obviously, with less than other ones, I have it also. So please watch them and just search for them. And similarly, if you just do class for object-oriented Python, you have a number of Python classes, and class and objects. I even did the word cup. I remember I made a lot of videos. These are word cup with the class and objects. Each player was an object of player and class, and they were doing stuff. So just watch them and enjoy them and learn them. Similarly, if I just did the list is also, there's a lot of videos on that list here. You can see Python. These are all list, and somewhere on some of the, whether I did it on Linux or Windows, I covered them. So you can practice them and learn them. And there's a lot of short videos as well as long videos. So the shorts are made from the long videos. Okay, I hope you enjoyed it. Take care. God bless you all. Have fun and help others as much as we can. Take care. Bye-bye.